So our next objective is to construct what we call a simple random sample. So sampling, what we're really looking for is finding something what we call a representative sample. So a representative sample essentially is going to have a sample that's really kind of a match for the population. So it is going to be a sample with the same subgroups. By subgroups, it's like we have all our religious groups that we'd have in the population. We have all the same genders that we have in the population. We have all the same races we have in the population. Various things like that. We have all the same eye colors that you see in the population. So we're just making sure that whatever it is that we're really interested in, those subgroups show up in our sample. So a representative sample is a sample with the same subgroups with similar proportions to the population. So if your population is, 48% female, you want to make sure that your sample is also about 48% female. If your sample is, say, 3% Jewish, your population is 3% Jewish, you want to make sure your sample is roughly 3% Jewish. So you just try to keep it as close as you can. You can't do it perfectly, but that's the idea of a representative sample. So one of the ways we make those representative samples is through simple random sampling. So ideally, we would like our sample to represent the population as close as possible. Unfortunately, no method is going to guarantee this for us, unless we were like, the only thing that will work is collecting everybody, which then we're not really sampling anymore. So any sample we collect is always going to be a little off from the population, but what we're trying to do is minimize that difference as much as we can. Best sampling methods often involve a random selection. So that means that anybody who is in the population, should be able to, at random, just pull one person out of there. That means everybody has the same chance of being in your sample. The most basic, and in most cases the best sampling method, is what we call a simple random sampling. The idea of a simple random sampling isn't too difficult. So a simple random sampling of a size n, we don't know what the size is, just some size, is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample. So what that means is that each, let's say I wanted to collect, I wanted to sample NLC students. Every group of 10 students that I sample should be just as likely to be sampled as the next 10 groups, meaning that all my groups have the same chance of being sampled. So let me make myself a little group here. So let's say these are a whole bunch of people. So what we're saying here is that this group of 3 people here have just as equal chance of being selected as, say, this group here, and it's just as much chance as this group here, and it's just as much chance as this group here. So every time I make a grouping of 3 people, no matter how weird that grouping may be, all those groupings of 3 people have the same chance of being selected. Is really what we're trying to say. It's really what a simple random sample is. So this is analogous to a lottery. So if we had 10,000 lottery tickets are sold and 5 are drawn as the winning tickets, each collection of 5 tickets that we draw out, so let's say there's an infinite amount of realities, every one of those realities has the same chance of 5 tickets being, each 5 tickets of being drawn are going to have the same probability of happening. So the problems with simple random sampling kind of come up later, that it's really hard to make something truly random samples. Uh, there's some issues with the probabilities when that's involved, which you don't have to worry about yet. But generally, if you have a really big population and a significant sample size from it, you should have what you should have is essentially everything's a simple random sample. So my first example here, so once again, you can pause and take a look at this. A physical education professor wants to study the physical fitness levels of 2,000 students, 20,000 students, sorry, enrolled at her university. She obtains a list of 20,000 students, numbers them through 1 through 20, yeah, 1 through 20,000, and uses a computer random number generator to generate 100 random integers between 1 and 20,000, and then invites 100 students corresponding to those numbers to participate in the study. So what this means is that each person gets assigned a number. And we're going to go through from 1 to 20,000. So I'm not going to write them all down here because we'll be here all day. I mean, even these like 6 here I have, it's taking a long time. So we would label each student. And a random number generator just will randomly generate numbers. So it's like rolling a dice. If we had a 20,000 sided dice and we kept rolling it, that would give us random numbers. So we just keep on rolling, getting different numbers, which is essentially what a random number generator does. And we're going to do this, generate 100 random integers. So we want to know, is this a simple random sample and why? Well, I would say yes is a simply random sample because if I select 100 people, there's nothing that makes one group of 100 more likely than another. So each group of 100 people have the same chance of being selected. Okay. So we sampled somebody, we sum aside, we generate again, we sample another person, but there's nothing that makes that one sample's probability any different than another sample. So that's what we mean by it being simply random. So by the fact that each group of 100 people has the same chance of being selected, this makes it simply random. So this makes our sampling a simple random sample. I'm sorry about the dog barking. It's my neighbor's dog. It's easy to record from home. So example 2, a professor in the last sample now wants to draw a sample of 50 students to fill out a questionnaire about which sports they play. The professor's 10 a.m. class has 50 students in it. So she uses the first 20 minutes of class to have the students fill out the questionnaire as this is simply random sample. So I don't know how many students she has, but this group of 50 does not have the same chance of being selected as another group of 50. So she has, at least 3 classes probably she's a professor. Probably more closer to like 5, but let's say there's about 50 students in each class. So what she did is she picked just one of those classes. So let's say this is what her schedule looked like. She just picked this one of 50. There wasn't an equal chance. So not every group of 50 students has an equal chance of being selected. Because they do not all have an equal chance of being selected, this means this is not random, simply random. So this is not simple random sampling. Okay. So what the problem we have here is that these classes are going to have pretty much, there's going to be something different about these students. Students who take a 10 a.m. class or 12 a.m. or 2 p.m. class, there's going to be something slightly different to it. It's a possibility that this university offers a, like maybe a nursing class, but the only time they offer it is 2 o'clock. So that would ensure that this class would have no nursing students. So if that happened, like I said, a situation like that, that means is that one of your, if you're teaching pretty much any college, you're going to have a nursing program at some point. And what we'd have here is that this wouldn't be, each of one of these groups would not be representative, because if I selected, say this one would have no nursing students in it. Maybe the 10 a.m. class is more likely to have parents in it. So if you selected this class, you might end up with more parents than you would have with another sampling. So the problem is that when you